Hello everyone, and welcome to this video on implementing an artificial intelligence algorithm for image classification using Python and the TensorFlow library. This code trains a neural network model to classify handwritten digits from the MNIST Dataset. It preprocesses the data by normalizing the pixel values, defines the model architecture, compiles it with a loss function and optimizer, trains it on the training data, evaluates its performance on the test data, and makes predictions on a sample of test images. Import the TensorFlow library, which is a popular open-source machine learning framework. Load the MNIST dataset using the load_data function from the tf.keras.datasets.mnist module. The MNIST dataset contains 28 by 28 pixel images of handwritten digits, 0 to 9, and their corresponding labels. Preprocess the data by dividing the pixel values by 255.0 to normalize them between 0 and 1. This helps the model to learn better. Define the model architecture using the sequential API from Keras, which is a high-level neural networks API. The model consists of a flattened layer that converts the 28 by 28 image into a 1D array, a dense layer with 128 units and a ReLU activation function, a dropout layer that randomly drops out 20% of the units to prevent overfitting, and a dense layer with 10 units, one for each digit, and no activation function. We'll use the from_logits equals true argument in the loss function instead. Define the loss function as sparse categorical cross-entropy, which is suitable for multi-class classification problems like this one. We set from_logits equals true because the last layer of our model has no activation function, so its outputs are logits, raw predictions, rather than probabilities. Define the optimizer as Atom, which is a popular optimization algorithm for deep learning. We'll use the default learning rate of 0.001. Compile the model with the loss function and optimizer, and specify accuracy as a metric to track during training. Train the model on the training data for 5 epochs, iterations over the entire dataset. This updates the model's weights to minimize the loss function. Evaluate the model on the test data to see how well it generalizes to new, unseen data. This prints the loss and accuracy metrics for the test set. Use the trained model to make predictions on the first 5 images in the test set. We apply the softmax function to convert the logits into probabilities. Print the predictions, which are arrays of probabilities for each digit class, 0 to 9. The model predicts the digit with the highest probability as the output. And that's it. Thanks for watching, and see you next time.